Industry-academia partnerships are absolutely essential for innovation. Complementarity of skills and knowledge is strength and helps to bridge the gap between research and clinical products. Where the one side knows the ins and outs of their unmet clinical need and has the domain knowledge, the other side has the technical expertise and can help to create and market a product. And not only that, but it can be clinically approved by regulatory bodies, which is something practically unachievable by us in academia. One of the advantages actually of having such an industry academic partnership, such as the one we have with Aiforia, is also to reduce the turnaround time. So basically, when you have an idea and you want to bring it to market and you want to bridge this, Aiforia was really there to help us to do this in a quick way.
At Aiforia, we have a long history of working with research partners and customers using our Aiforia Create as the common platform for developing AI models for a multitude of purposes. These collaborations with academia are of utmost importance for us. By having researchers, pathologists, students, everyone using the same tool for building AI models opens a wealth of opportunities. Our collaboration with the University of Bern in Switzerland is a wonderful example of this. Since a couple of years, we've had their team build AI models, for example, for H. pylori and lymph node metastasis detection, for their own research purposes and for Aiforia's product development. Having the many insights from their research work helps us shape the products that we bring to the market for clinical practice. Also, as part of our collaboration, we do get to leverage their images, their annotations from University of Bern in the actual product development. And of course, for any AI algorithm training, access to high quality data is imperative. With the University of Bern, we obtain data that has been prepared and documented according to the highest standards with their Swiss accuracy. This makes the overall process of getting to high algorithm quality very, very efficient.
The main thing that I really valued about working together with Aiforia is that you always can reach out to them and you will have an answer via email if things can be clarified, in a few sentences. But then if you reach out to them and you request a meeting to discuss like more complicated things or to get their advice on how to continue with a project or how to modify an algorithm, they have been very helpful with us. So the overall experience that we have was a very positive one.
We are very, very proud to launch our new lymph node metastasis product that results directly from this collaboration. Using the models and training data from our collaboration as the core and starting point, we have taken this model through our development processes and finally through CE-IVD clearance. This makes a great proof point of how collaboration between academia and industry can result in solutions that will improve healthcare.
The Aiforia lymph node metastasis model is an AI-powered image analysis that scans H&E whole slide images of lymph nodes and highlights even the smallest metastatic foci from breast, colorectal, and melanoma cases. It is trained on thousands of expertly annotated images in collaboration with the University of Bern and fine-tuned in the Aiforia clinical suite. It carries the CE-IVD mark for diagnostic use across the EU and EEA. Why did we develop the AI lymph node metastasis model in collaboration with the University of Bern? It's because lymph node screening is one of the most labor-intensive steps in cancer staging. A single case can require the pathologist to go through tens or even maybe hundreds of slides under time pressure. By automation, the read and flagging of suspicious regions frees up the pathologist to focus on interpretation and reporting and not exhaustive searching for the metastasis. What challenges does the model solve? There are three main challenges. First, the sensitivity. With over 98% detection accuracy means virtually no metastasis goes unseen. And also the negative cases can be relied upon. Number two, the efficiency. From our data, it shows that the pathologists can be up to 40% faster in their workflow, translating into more cases per day without extra staffing. And thirdly, consistency. Objective heat maps and quantitative outputs reduce intra-observer variability and supports standardized cancer staging across the sites.
We found that using this model, we really have a great AI companion. So the current model, it really does not miss anything. So it is very sensitive. So you basically do not miss any lymph node metastasis. So if I screen lymph nodes in a rather quick fashion with a conventional or digital microscope, and I don't see any metastasis, then I will also ask the model what its outcome is. And if the model is also negative, then I'm very reassured that I did not miss anything. But the overall outcome is that it saves you a lot of time in the end, and also increases really the accuracy of your diagnosis.